In this video, we will be looking at some more quadratic applications when we have equations in factored form or standard form. But for all of these examples today, we will be creating our own quadratic equations to solve or find the vertex. So let's start with the first one. The length of a rectangle is 3 centimeters more than double the width. The area of the rectangle is 119 centimeters squared. What are the dimensions of the rectangle? If we are asked for the dimensions, those will be our let statements. Let L represent the length. Let W represent the width. And now let's reread the question, and hopefully we can come up with one or two equations to represent it. So the length of a rectangle is 3 centimeters more, that implies addition, than double the width, that implies multiplication. So length is, so L equals 3 more, so I have to add 3 to something, and I have to add 3 to double the width. Doubling the width means 2 times the width. Okay, there's our first equation. Now, this is definitely not quadratic, but it might help us out later on. Let's read the next statement. The area of the rectangle is 119 centimeters. We know area of a rectangle is length times width. So instead of this, I'm going to write length times width equals that area that we were given, 119. Notice I'm not putting the units into my equation. And the squared is just the unit, centimeters squared. Okay, this is also not quadratic. However, I do have a nice equation here that represents the length, so I'm going to do a little substitution. I'm going to replace L with the 2W plus 3. Now, when you see this, it might not look the greatest. I mean, in reality, we are just multiplying the W into the bracket, but if you don't like how this looks, just switch around the multiplication, because when we multiply things, the order doesn't matter. Now we can more clearly see, all right, we have to distribute the W in because our goal here is to find dimensions, which means solve the equation. And if I want to solve the equation, everything has to move over to one side, so I have to standardize it first, and then I can factor. So W times 2W is 2W squared, W times 3 is 3W, and I'm also going to bring the 119 over at the same time. It's now negative, and that equals 0. Now I can do a little crisscross. So 2W times W for sure. And then for 119, I'm going to take that number and start dividing it by different numbers. Not an even one. Maybe I can try by 3. Doesn't work. Maybe 7. And 7 gives me 17 times 7. So I know I need to get a check that's 3. So I'm going to try putting the 17 here, the 7 here. One of them is going to have to be negative. But this is 17W. This is 14W. If the 14 were negative, that would be perfect. So I'm going to make the 7 negative. And now these do add up to 3W. So that's great. So 2W plus 17 and W minus 7 equals 0. Now we can branch out and solve this equation. And we are solving for the width here. So 2W plus 17 equals 0. Bring the 17 over, divide out the 2. I could also write this as a decimal, but it doesn't matter because a negative width does not make sense. It's inadmissible. The other branch, W minus 7 equals 0, and W, or the width, is 7. That is logical. Great. I have half of my therefore statement. I also need the length. And thankfully, we have this nice equation here about the length. The length is double 7 and 3 more than that. So 2 times 7, 14, plus 3 is 17. And there are my dimensions. Then I can do a little check. 7 times 17, it is the area of 119 centimeters squared that I needed. So I'm confident, and I can write my therefore statement. Therefore, the rectangle is 17 centimeters by 7 centimeters. And that's it. Set up the equation. We had a linear equation and something that became quadratic, and then we were able to solve for it. Let's look at the next one. An 8 meter by 5 meter rectangle is surrounded by a uniform border on all 4 sides. The area of the new rectangle is 108 meters squared. Find the width of the uniform border. So first thing, I'm going to do a diagram here because it's not just a rectangle and we're given some information about length and width. So we have a rectangle that is 8 meters by 5 meters, and there's a border around this rectangle. And it's uniform, so the width of each side is the same. So this portion here, this portion here, here, and here is all the same, and that's actually what we're looking for. So I'm gonna label that as W all the way around the width of the border, and I'll write my let statement. Let W represent width of border. Okay, that's great. And what other information are we given? We're given the fact that the area of this new rectangle, this enlarged one, is 108 meters squared. Well, we know area is length times width. I have the area. If I can come up with an expression for this new width and this new length, we would be perfect. So let's take a look. The width used to be 5 meters across this way, and then we added W here and W here. So we started with 5 and we added W twice, so 5 plus 2W. Likewise for the length, we started with 8 and we added a W on top and 1 on the bottom, so we added 2 W's. And now we're ready. New length, so 8 plus 2W, times new width, 5 plus 2W, equals new area, which is 108. The hardest part is done. We just set it up, and now we're solving the quadratic equation. I know I need to bring everything over to one side, so the 108 has to move over, which also means I have to do some distribution here to get it into a nice standard form before I factor. So 8 times 5 is 40, 8 times 2W is 16W, 2W times 5 is 10W, and 2W times 2W is 4W squared. And then the 108 moves over, and now the other side is 0. Now let's collect our like terms. So we have the 4W squared, the W's collect to 26W, and then 40 minus 108 is negative 68. Now I can do crisscross from here, but I would like to make my numbers a little smaller, so I'm going to factor out a 2. So I'm dividing each coefficient by 2. And now I'm going to crisscross what's left in the bracket. So 2W times W, and for 34, I'm thinking 2 times 17. I think the 17 should be on its own with the W, and the 2 goes with the 2W. I'll try that negative. So 17W, negative 4W, that does add up to the 13. Fantastic. So there's my GCF. There's my first bracket and my second bracket. And now branch out and solve for the width like any solving question. Set it equal to 0, bring the 17 over, divide by 2, and we do get a negative number, so that's not logical. It's inadmissible here. But the other one, when we bring the negative 2 over, we get positive 2 for the width, which does make sense. So therefore, the width of the border is 2 meters. Now, if I wanted to do a logic check, I can figure out what the actual new length and width is. So let's look at the width. It started as 5, and we added 2 on each side, so we added 4, that's 9. We started with 8 for the length, and we added 2 on each side, so 8 plus 4 is 12. and 12 times 9 is 108 for the area. So I am confident with my answer here. All right, let's get away from these area-related rectangle questions and try something else. Here's an integer question. The difference between two numbers is 8. Find the numbers if their product is a minimum. Well, this is different wording here. I see the word minimum, so they're not giving me the product like I was given the area in previous questions. They're telling me to find something that is a minimum. Anytime we see the word minimum or maximum, we should be thinking vertex. This is a vertex question, which means at some point we're going to find the zeros to find that middle value and get our vertex. But first, let's write some let statements. We're looking for the numbers. Those are going to be my let statements. Let x represent first number. Let y represent second number. And this is about product, and we're not actually given the product. So I'm also going to write let p represent product. Okay. Actually, I'll just start with that. The product is a minimum. I need to find the vertex of the product equation. Product means multiplication. So product equals x times y. So product equals first number times second number. Obviously, this isn't quadratic yet. I can't find the vertex of this, but maybe this information here, the difference between the first or between the two numbers is 8. Difference means subtraction. So x minus y should give us 8. And now I have something where I can isolate for a variable. I'm just going to isolate for x this time. And we'll have 8 plus y. Okay, great. Now I can replace x with 8 plus y in my product equation. Product equals 8 plus y times y. Now, I do want to find the vertex, and like I said, we should find the zeros first. If we want to find the zeros first, we should set the product equal to 0 to show that we're going to be solving for the zeros, and lucky us, this is already factored. The y is like the GCF. You can put it in the bracket, you can put it out front, doesn't matter. So I'm going to branch out. Y can equal 0, or 8 plus y can equal 0, meaning y equals negative 8. Those are the zeros. If I want the vertex, I know the vertex will be right in the middle of these two numbers, so I'm going to average them. Add them and divide by 2. Now, these are y values, so I'm going to write yv. And that's going to be negative 4. Now, y represents the second number, so our second number is negative 4. The question doesn't actually ask me to figure out the minimum product, so I'm not going to take this negative 4 and put it into this product equation because I don't care. It's just asking me for the numbers. I know my second number, great, so I'm going to take this and put it into my first number equation. So I'll have x equals 8 plus negative 4, which is 4. And that's my first number. Now I know my numbers. If I want their product, 4 times negative 4 is negative 16. There it is. Therefore, the numbers are 4 and negative 4. And again, the clue here that we were looking for the vertex, which is nothing new to us, finding the vertex, but the key word in the word problem was the word minimum. Okay, back to another rectangle question. You have 12 meters of fence for a rectangular area. What are the dimensions of the maximum area you can enclose? Okay, so I see the word maximum. It's going to be vertex. And it's going to be the vertex of the area equation. And the question asks for the dimensions. So, my let statements. Let L represent the length. Let W represent the width. And I'm just going to do a little sketch. Okay, I know I'm maximizing area, so I'm actually also going to write let A represent area. And now I know I need to find the vertex of this equation, which not quadratic just yet. Okay, we are given information though. We have 12 meters of fence, which means this length, this length, this width, all need to be covered by that 12 meters, which means 2 lengths and 2 widths should add up to 12. No more, no less. I'm going to isolate whichever variable I want. I'm choosing to isolate for the length. So I'm going to bring the W over so that it turns negative 2W, and then I will have to divide everything by 2. And we get L equals 6 minus W. That's great because now I have this equation that I can go sub into L in my area equation, and that will turn it quadratic. Area equals length, so 6 minus W times W. And because our goal is the vertex, I'm going to find my zeros first, which means replace A with 0. And now we can branch out and solve because, lucky us, this was in factored form again. So W is 0, or 6 minus W is 0. I'm going to bring the next negative W over so that becomes positive. And now my zeros are 6. Let's get the middle number. So the width coordinate of the vertex is 6 plus 0 divided by 2, which is 3. Again, I don't actually care what the maximum area is because it didn't ask for it, so I'm not going to plug into the area equation. I'm going to go into my length equation. And 6 minus 3 is 3. So therefore, a 3 meter by 3 meter rectangle will maximize area. All right, one more, and this one we're just gonna set it up because it is very similar to the previous example, just with a little tweak. A rectangular garden is to be divided into 3 sections. That's the new part. If there are 24 meters of fencing available, fantastic, that's going to help us with our side note equation. What dimensions will maximize the area? Okay, same let statements. We need length and width. Let L represent length. Let W represent width. Let A represent area, because that's what we're trying to find the vertex of. And we know area is length times width. I don't know area, I don't know length, I don't know width, so that's all we got so far. Now, in terms of this 3 sections and how it's going to affect that 24 meters of fencing, here's my rectangle. Here's the garden, the length, the 2 widths, and the other length. This time we have 3 sections in this garden, which means I need to put in another 2 widths that are going to be fenced off so that I have 3 sections. So now that 24 meters of fencing is covering 2 lengths and 4 widths. And now we can go ahead and rearrange. So again, I'm going to isolate for L because I'd rather divide out 2 instead of 4. And then we can divide both sides by 2. And we get the length is equal to 12 minus 2W. And now we can sub it in to get that nice quadratic equation. And because the goal is to find the vertex for that maximum, I would set my area equal to 0, find the W's, the zeros here, and then find the middle vertex, the middle value to get the vertex. And that's it. So again, reading the question carefully, whatever you're being asked to find, those are your let statements. There should be 2 statements in there to help you come up with 2 equations. Maybe a diagram is helpful for some of these rectangle scenarios. And that's it.